Hey, what's up, guys? This is Chung here again. So, LeetCode number 1981, minimize the difference between target and chosen elements. Okay, so this one is pretty straightforward. Basically, you're given like m by n integer matrix and an integer target. So your task is to choose one number from each row, right? And then you got a sum for all the number you have chosen, and you want to minimize the difference, the absolute difference between the target and the sum, right? So that's it. So for example, we have this matrix, right? So we can choose 1, 5, 7, where the sum will be 13, right? And the target is also 13. That's why the answer is 0, right? So for this one, we don't have any other options, right? That's why we have to choose these three numbers, and the absolute difference is 94, okay? And for this one, right, this one is 7, right? Because 7 minus 6 is 1. Minus 6 is 1. And then we have some constraints. So see, we have 70, right? And 70, and then the target is 800, right? So since the the constraint is not very big, we can probably just use like what the some kind of brute force way to solve it. But we still need to use the dynamic programming. Basically, like I said, since the m times n and this one is also within 70. So what does it mean? It means that the total sum in the end will be less than what? Will be less than 70 times 70, right? Which is 4,900, right? Because for each row, the biggest number is 70, right? And for 70 rows, that's 70 times 70, right? So basically, that's the total number of different sums we can get, right? So which means we can simply just use this one, right? As part of the state, and the first one obviously should be the row, right? So basically we can have like 2D dynamic programming, right? We basically the first state is the row and the second one is the sum, okay, right? And then in the end we just need to get the minimum of this DP state. Uh, let's start coding. Yeah, I'll explain more. So the state transition function is very straightforward, right? So like I said, we have 2D state. The first one is the row, right? The current row, and the second one is basically the current sum, right? That we have already picked, right? And then we have this cache, right? Thing. So what's the base case, right? So the base case is this. So basically, when the row is reached the end, okay, the m is going to be the length of mat, right? So when we have reached the last row, right, we just return the absolute difference, right, between the sum and the target. So that's the basic rules, right? And then so the state transition function is like this, right? Like and then for num, okay, in mat row, right? So for each row, we do the answer equals to minimum, right, of the answer dot dp of row plus 1, then the sum plus number, okay, and then we return the answer, right, and then here we return the dp of 0 and 0. Okay, so that's the basic implementation. So so we have this 2dp state, right? Basically it means that we could the reason we're using dp here is because we could end up with from multiple path, right? Okay, let's say this is the path. So let's say this is the path. Let's say we go here, right? And then we go, sorry, not here, like this one, right? And then here, here. Let's say this two path, right, will end up with the same state, which means that the numbers we're collecting from this one, this one, this one, and this one, this one, and this one will give us the same sum, right? In this case, we don't have to calculate this dp. We can only just use one of the path. We don't have to calculate the remaining parts multiple times, right? That's the reason we use DP, right? To remove the duplicated path. Okay, and but this one will fail, will TLE. I think the reason is that even though the see we have 70, so let's take a look at the time complexity for this one, right? So the DP time complexity, how to analyze it is the total number of the states, right, multiplied by the time complexity for each of the function for each of the DP call, right? So how many states we have? Let's say we have n, right? So n is like the 70, right? So we have n times sum, right? Like I said, the total sum, the possible number of sum is like what's n squared, right? Because we have already talked about that. And then inside of the DP function here, this one is also n, right? So basically it's going to be n to the power of 4. Okay, 70 to the power of 4. This one I think it's about 2 million. 2 million, right? For some reason this one TLE, it couldn't pass, so which means we need to do some improvement, or like you call it pruning, right? So what can we do? So first thing is that we can always remove the duplicate, right? The duplicate for each of the row, right? So that's the first thing we can do. Which means we can do this, right? For I in range of m, right? We have a mat I equals to the set. We can simply do a set of the mat I, right? So that's how we remove the duplicate. But this one's still TLE. And what's another thing we can do? What we can improve is that we can sort. Because first we all the numbers are positive, right? So which means that if the sum is too big, right? Basically, if by the time let's say we have a lot of rows here, right? So let's say we're trying to process this row right now. Let's say after picking this number, let's say this number is 4, right? This total sum has already exceeded the target, right? And then let's say, for example, this row also have like some 6, 7, and 10, right? Then obviously we don't need to try 6 any number that's greater than 4, because 4 plus the sum has already exceeded the current target, right? So we can simply stop that, right? So which means that in order to accomplish that, we can just sort each row so that we process from the smallest to the biggest, right? The moment the current sum has already exceeded the target, we can simply break the for loop, which means we can simply break here, right? So that we don't have to try 6, 7, and 10. We can simply stay with its 4 and then try the remainings. Okay, right? So to sort, we just simply need to do a little bit of modification here. We just do a sorted of the set, right? Then we will have like sorted list here, and here, basically, if the sum plus number, right, is greater than the target, okay, right? I think either greater or equal is fine. Yeah, it doesn't really matter, I think. And then we break, right? So that's it. So now if I run it, it's accepted. Yeah, there you go, right? So it's not that fast, but it passed. Okay. Yeah, I think that's it, right? I mean, that's the uh kind of standard DP problem with two state plus some pruning to pass all the test case. Yeah, I think that's pretty much everything I want to talk about for this one. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.